So in this video, we're going to see questions from chapter number 13, surface areas and volumes. We are going to see questions from exercise 13.8. So we've already seen few questions which are related to the volume of the sphere. Now we're going to focus on the volume of hemisphere. Okay. So let's read this question number 5. How many liters of milk can a hemispherical bowl of diameter 10.5 centimeter hold? Okay. We have to calculate the total amount of milk. Okay. Milk that a bowl can hold, and the shape of the bowl is hemisphere. Okay, hemisphere. So indirectly we have to calculate the volume of the hemisphere. Now the diameter is given to be 10.5 centimeter. So let's make a note of that. So the diameter, so this is the diameter. Okay, so I'm going to just write here d. The diameter d is equal to 10.5 centimeters. Okay, and we have to calculate the volume of the sphere. So now let's come down and focus on this diagram. So we know that volume of a hemisphere, so volume of hemisphere is nothing but it's the half the volume of the sphere. So volume of sphere is 4 by 3 pi r cube. This is the volume of the sphere. Hemisphere we know by definition is half of sphere, so I'm just going to do a half the volume of the entire sphere. So this translates to 2 by 3, okay, pi r cube. This is a standard formula to calculate the volume of a sphere, 2 by 3 pi r cube. Now, diameter is given to us, which is 10.5 centimeter. So radius is basically half of diameter. So let's substitute that. So this is going to be equal to 2 by 3. We'll take pi as 22 by 7, okay. And radius, I'm going to write here. So this is our radius cube. And now what is our radius? Radius is half of diameter. So I'm just going to substitute 10.5 the whole divided by 2. Okay. So this entire expression, this entire mathematical expression is going to give us the volume of the hemisphere. So now no need to worry about the diagram. Let's focus on how to evaluate this mathematical expression. So okay. So this is now again equal to 2 by 3 into 22 by 7, okay, into, we are just going to expand this. So 10.5 divided by 2 multiplied by 10.5 divided by 2 multiplied by 10.5 divided by 2, okay, because it's a cube, so 3 times. Now you must have noticed that 7 divides 10.5. So let's do that first. So 7 into 1 is 7 and point and 5. Okay, 1.5. Basically 7 into 15 is 105. So that one is decimal. And now this 3 is also there. So 3 again divides this. This is going to be 0.5. Okay, 3 into 5 is 15. So that decimal 0.5. And then further this 2 and this 2, they will cancel each other. And this 2 and this 2 will also make it 11. 2 into 11 is 22. Okay, so what remains in total now is 11 into this 0.5, so 0.5 into 10.5 into 10.5. okay, this is the volume of our hemisphere. Now we have to do these calculations. This is equal to, so okay, let's use a calculator to find the value of this. So this is equal to 606.375 centimeter cube. This is very important. The unit is going to be this is decimal 606 point. The unit is going to be centimeter cube. So because because the diameter was given to us in centimeter. So this much centimeter cube is the volume of the hemisphere. Now that is not the end of the question. Okay, let's read the question again. The question asks us how many liters of milk. We want to find out the value of the milk in liters. However, now we have the value in centimeter cube. So now we should know how much centimeter cube is equal to 1 liter. So we must, okay, so you guys must know that 1000, okay, 1000 centimeter cube is equal to 1 liter of the value. Okay, it's just a different conversion matrix that we use to denote the volume of any liquid. Okay, so liters, 1 liter is actually 1000 centimeter cube, but our volume of hemisphere bowl has come to be this, so it will be how much liters? Therefore volume, okay, volume of hemisphere, I'm just going to write it H, hemisphere in liters is equal to how much? So it's going to be 606.375 the whole divided by 1000. Okay, so that is going to be roughly 0.6 liters. So 0.6 liters is the value of the milk, okay, is the amount of milk that our hemispherical bowl is going to hold. Okay, be very careful. Don't just end your solutions by finding the volume of the hemisphere, because that is the value in centimeter cube, and the question asks to find out the value in liters. Okay, so to again just divide it by 1000, and I'm just going to write here very quickly. So how much liters? Is roughly equal to 0.6 liters of milk that the bowl is going to hold. Okay, that's it. Now we move on to next question. So, but before we move on to next question, let's erase this. Okay, let's again zoom in. It's another interesting question with respect to sphere. So sorry, with respect to hemisphere. So let's get this down. Okay. Okay. Let's erase. Let's get rid of this. Or okay, fine. Let's get rid of this. Delete. Okay. So we have to focus on question number 6 and not question number 7. That's the whole thing. And for this, I'm going to move this a bit here. Okay. Cool. So now let's read what the question number 6 says. A hemispherical tank is made up of iron sheet 1 centimeter thick. Okay. The other question is distracting, so I'm just going to increase the size. Yes. Just keep it like this. Okay. Now I'll read the question once again. A hemispherical tank. Okay. So this is our hemispherical tank made up of iron sheet 1 centimeter thick. So this iron sheet is 1 centimeter thick. If the inner radius is 1 meter, then find the volume of the iron used to make the tank. Okay, we have to find the total volume of the iron that has been used to make the tank. Now, first of all, let's try to understand the situation that is given to us in a diagrammatic format. It's a little bit tricky, and you have to extend your imagination to visualize what is the actual figure of this hemispherical tank. Okay, so hemispherical tank is made up of iron sheet which is 1 centimeter thick. So what I'm going to do is, okay, so let us assume, okay, so let's say this is the thickness. Okay, 1 centimeter thick, right? 1 centimeter thick is our hemisphere, which means now I'm going to make another diagram. So something like this it's thick, so like this, and we are going to have this because it's 1 centimeter thick, so this like this hemisphere. Okay, so this thing I'm going to use highlighter now. This thing, this is 1 centimeter thick. Of course I have exaggerated it a lot, just zoomed in a lot, but this thing is 1 centimeter thick. Yes, let me in fact make a note of that. So this is 1 centimeter thick, 1 centimeter thick iron sheet. Okay, so try to visualize, this is our hemispherical tank. Okay, this is the tank, the actual figure, and the one which I have constructed in the orange is just the 1 centimeter thick iron sheet. Okay, so this whole thing is basically iron, 1 centimeter thick iron. Now the inner radius is 1 meter. So let's quickly make a note of it. Now we know what is the inner radius. So if this is the center, okay, if this is the center, so this is our radius, and that is 1 meter. Okay, the inner radius is 1 meter. Why are they saying inner radius? Because if you add this 1 centimeter, then you will get the outer radius, which will be 1 meter plus 1 centimeter. Okay, don't do 1 plus 1 2, because this is in meters and this is in centimeters. Okay, so we'll come to that part later, but right now let's represent whatever information is given in the question in our diagram. So if the inner radius is 1 meter, so this is our inner radius 1 meter, then find the volume of the iron used to make the tank. So this is our huge tank, whole big tank. We have to find the volume of this 1 centimeter thick part. So this thing which is given in orange, we have to find its volume. So first of all, let's try to think, how are we going to find the volume of this, okay, this orange color tank? It's quite simple. Now let me try to come down here. Okay, the way we find that is actually the volume of this whole tank, the outer tank, minus the volume of this inner hemispherical tank. Okay, Both of them are hemispheres. So if you find the volume of this whole big tank, the orange tank, and subtract the volume of this inner, this black tank, then we'll get the volume of the thick 1 centimeter thick sheet, total volume of the ion used. Okay, so this is a very important conclusion, this is very important observation rather, that you have to arrive at while solving this question. So I'm just going to write it down. Okay, let's write down here. So okay, volume of ion used, volume of ion used is equal to what? So that is equal to volume of, I'm going to say volume of outer sphere. Let me write here outer, it's not sphere actually, outer hemisphere. So I'm going to say volume of outer hemisphere minus volume of inner hemisphere. So inner hemisphere. Okay. Volume of outer hemisphere minus the volume of inner hemisphere is going to give us the volume of the ion used. Okay, very important. Now, what is the formula to calculate the volume of hemisphere? So outer hemisphere, I'm just going to say 2 by 3 pi r cube minus 2 by 3 pi. This is also r cube, but let's make this r1, let's make this r2. Okay, just to have a different notations. So to find the volume of the outer hemisphere, we need its radius r1 cube. So what is the radius of the outer hemisphere? This is inner hemisphere, 1 meter plus 1 centimeter. That is going to be 1.01 meters if you want to keep it in meters. Okay. So let us first of all, let us take these common elements outside. So our calculations become simple. So now this is equal to 2 by 3 pi, which is common, and we are going to have r1 cube minus r2 cube. Quite simple. Okay. So this is equal to 2 by 3. Let pi remain as it is. First we'll figure out the inner brackets. Okay. So R1, okay, R1 is nothing but the outer hemisphere. So what is the outer hemisphere? 1 meter plus 1 centimeter. So I'm just going to write it down. That is equal to 1.01 the whole cube. Okay, minus R2. So let's R2. It is nothing but the volume of inner hemisphere. So we know that this inner hemisphere, it has a radius of 1 meter. So let's come down again. That is equal to 1 meter. So it's just basically 1 cube. Okay. I hope it's not very confusing and clear that how we arrived at 1.01. Okay. It's basically 1 meter plus 1 centimeter. Okay. So because 100 centimeter is 1 meter, so it's going to be 1.01. Okay. Okay. So that's it. Now all we have to do is find the value of this mathematical expression, and we are going to get this volume of the ion used. Okay. Now first we should know what is the value of 1.01 cube. For that we are going to use the calculator. So let me just find it out. So 1.01, okay, into 1.01 into 1.01. Okay, that's 1.03. Quite a small value. So that is 1.03. So let's continue. This is 2 by 3 pi. So this is 1.03 minus 1 cube is as it is. So that is just equal to 1. So now 1.03 minus 1 is going to be 0.03. So that is equal to 2 by 3 pi multiplied by 0.03. Okay. So now once again, these two values will cancel each other out. So let's do that. So 3 multiplied by this will be 0.01. Okay. Now let's continue. 2 into, let's write pi as 3.14. Okay. Into 0.01. So now that is equal to, what is 2 into 3.14? It's 6.28. Okay. Multiplied by 0.01. And that is going to be equal to 0.0628. This is meter cube. Okay. The unit is very important. This is the meter cube. And this is the volume of ion that was used to make this hemisphere. 0.0628 meter cube. Very small amount of ion is used, because although the figure looks quite big, but we know that this is just 1 centimeter thick. Actually this is very big hemisphere of 1 meter. Okay, and the thickness is very small, 1 centimeter. Just to understand it in a better way, we have made this huge diagram. But since this is just 1 centimeter thick, the volume of this entire orange iron hemisphere is also going to be very, very small. And as we have found it out, it is 0.0628 meter cube. So this is how you calculate the volume of the iron. The important part in this entire question was exact visualization of what is the scenario that is given in this question. If you mess up with this diagram, if you draw an incorrect representation of the hemisphere tank, then your entire calculations and the thinking process will also be in an incorrect direction. So that's very important. A diagrammatic representation should be very perfect and very accurate, and then you go and solve the questions. Don't be in a hurry to solve the question, note down the equations in a very hurry manner. You just first get a good diagrammatic representation, accurate diagrammatic representation, and then you can easily solve the questions once you have everything in place. That's all.